Hello student, in this video we will study about the covalent bond and their Lewis structure, how to write the Lewis structure of the covalent bonds. So here is a first example of methane gas, and whenever we write the methane, so you can see methane have the carbon and hydrogen, so both are non-metal and they are forming a covalent bond between to each other. And how to write their structure. So to write the structure we need to find out total valence electron are in their methane. So carbon have 4 electron and hydrogen have only 1 electron. And if you will count total electrons, so carbon have 4 and 4 hydrogen have 1 electron each, so total 8 valence electron will be there involved in the sharing of electron between carbon and hydrogen and to make a covalent bond. So let's see how they share the electron to make the covalent bond between the methane and methane. So basically you can see there is a 1 carbon and 4 hydrogen are surrounded or around the carbon. So carbon atom is considered as a central atom. So what is the meaning of central atom? Central atom is the first element which is least electronegative element. So we have just studied about the electronegativity in the previous slide, previous video, and so you can distinguish what is the least electronegative in between the carbon and hydrogen, and carbon is considered as a central atom here. And then we have to write 4 covalent bond, 4 valence electron for the carbon, 1 2 3 4, and each electron for hydrogen, 1 2 3 and 4. So how many single bonds are there? There will be 4. And how many non-bonding electrons? So every how many non-bonding electrons are there in the central atom? 0. So there are no electron left as a non-bonded. All the electrons are used in the bonding. And how they will represent? So you can see they were represented by this single line, and single line means there are 2 electrons are involved, like this one, carbon hydrogen, carbon hydrogen, and carbon hydrogen. So when you will count the total electron for hydrogen, each hydrogen will have 2 electrons, like this one, 2 electrons for each hydrogen. And when you will count total electron for the carbon, there will be total 8, 1 2 3 4 5 6 7 8. So we will count like this one, like this. So Lewis dot structure can also be drawn with the line rather than dot. So we can also draw the structure. This structure is called the Lewis dot structure, but this can also be written like this in the line form, and each line represent 2 electrons, and a single line represent a single bond. So these are the some common rules for the Lewis dot structure and Lewis line structure are the characteristics. So next, how to write the Lewis dot structure. So there are some rules. Number 1 is count the total number of valence electron each in a molecule or ion. And number 2 is identify the central atom and place the other element around the central atom. Third is place 8 electrons around each element in the structure except for hydrogen. Hydrogen need only 2 electrons. Count the number of electrons that were placed in the structure and compare the number of electrons used in the number to the number of the actual present. Electrons are actually present. So these are the rules we will follow to write the structure. And In continuation of the Lewis dot structure rule, there are few more. If the number of electrons used is equal to the number of electrons actually present, the Lewis dot structure is complete. But if the number of electron used is larger than the number of electron actually present, you have to modify your structure to include multiple bond. Then rather than single bond, they might have double bond or they might have triple bond. There is no such 4 bond or 5 bond, only single bond, double bond and triple bond. So if number of electron used is larger than the number of electron actually present, then either we have to make a double bond or triple bond, and that will be enough to satisfy the octet rule and making Lewis structure. If the number of electron used is smaller than the number of electron actually present, place the excess electron on the central atom, and that will be called as a non-bonding electron. So central atom, for an example, nitrogen. Nitrogen have 2 electron, which is usually extra. It has total 5 electron, and for an example, ammonia. I'm just writing here ammonia. And ammonia, each hydrogen have 1 electron, and nitrogen have total 5 electron. So you can see it is used. Nitrogen have used its 3 electron to share with the 3 hydrogen to make a 3 single bond. And if we will count total electron for nitrogen, so there are 1 2 3 4 5 6 and 7 8, but these 2 electrons are not taking part in making the bond, so they are called non-bonding electrons. So let's see some example about Lewis structure, then we can understand better. So this is the first example, writing Lewis structure for PCl3. So first, according to Lewis structure rule, first we have to find out the total number of valence electrons, sum of the valence electron from all the atoms taking into account overall charges. And if it is an anion, means negative ion, if there is anion, negative ion is also involved, add 1 electron for each negative charge. But if it is the positive ion, cation, then we have to subtract 1 electron for each positive charge. So let's see in case of PCl3, phosphorus have 5 electron and chlorine has 7 electron. Valence electron, we are talking only about the valence electron. So total will be 26 electron. How we will write the 26 electron? So first write the symbol for the atom, show which atom are attached to which and connect them with a single bond. A line represent with the 2 electrons. So just phosphorus and single bond with the each chlorine. So that represent that each phosphorus is sharing 1 electron and chlorine is sharing 1 electron each. So there are 2 electron here, 2 electron here, 2 electron here. To total 6 electron we used, only 20 remain. So let's see where are the remaining electron will be there. So complete the octet around all the atoms bonded to the central atom. So first we have to complete the octet of each atom which is bonded to the central atom. So you can see it, if it is chlorine, this chlorine is forming the single bond, it means it has already 1 bond, 1 electron here and 1 electron from the phosphorus, and now we have to write 6 electrons. So 1 2 3 4 5 6 and 2 electron from here, 8 electron. So likewise here 6 electron, 6 electron. So total if we count 6 6 6 18, and 6 electron we have already used, so 20. So remaining 2 electrons are still there. So what will happen remaining the 2 electrons? So place any remaining electron on the central atom. So if any remaining electron will remain, that will go on the central atom, and these electrons will be called as a non-bonding electrons, and these electrons will be called the bonding electrons. So there are 6 bonding electrons, 2 non-bonding electrons. If there are not enough electron to given the central atom, an octet try multiple bond, then we will try. So this is another example we will study. So now we can count for phosphorus how many electrons: 2, 3, 4, 5, 6, 7, 8. So phosphorus has 8 electron, each chlorine has 8 electron. So this was one example. Another example is this. They said that if there are not enough electron to give the central atom, then make an octet. To make an octet, then try multiple bond. So what happened in case of HCN, hydrogen cyanide? So we can make first each single bond between each, and then figure it out how many carbon have 4 electrons basically, valence electrons. So 1 electron is remain here, 1 electron remain here, 1 is shared with this hydrogen, 1 is shared with this nitrogen. But if we will count the total electron for carbon, so 1, 2, 3, 4, 5, 6, still it need 2 more electron. So that is why nitrogen give 2 more electron to the carbon to share it. So basically nitrogen share 3 electron with the carbon and nitrogen have triple bond. So these 3 lines are called triple bond, and 1 lone pair will remain. Non-bonding electron pair will remain on the nitrogen. So this was the example of the Lewis structure. So let's see one more example. Example for ammonia. So ammonia have nitrogen and 3 hydrogen. Nitrogen have 5 electron in outermost shell, which is a 5 valence electron, and hydrogen have each 1. So total 3 from hydrogen and 5 from nitrogen. So total valence electron will be 8. What is the central atom? Nitrogen is the central atom. How many electron does nitrogen want? 8 electron it want. So, and how many electron do the hydrogen want? 2 electron want. So we will make 3 bond between one nitrogen and hydrogen, this hydrogen, and then this hydrogen. So it means 1, 2, 3, 4, 5, 6. So 6 electron has been used, and each hydrogen have 2 electron, and this nitrogen have total 6 electron right now. So how many single bonds are there? 3 single bonds are there. How many non-bonding electrons are there? Because 6 electron has been used and still there are 2 electrons, so they will go on the nitrogen and they will be considered as a non-bonding electrons. So these were the two examples about the Lewis dot structure, and next video we will study about some more example about the Lewis dot structure, how to write and how to follow their rule to apply the Lewis dot structure.